modeling linear data. We're going to do this with y-intercepts and the slope. So we have three different graphs here that we're going to play with. So the new student life director received the following graphs of account balances for different student groups for the first 5 weeks of the semester. He would like to write an equation that would model the balance in each account for a given week. All right, so have these three. So how are the graphs similar and what patterns do we notice? Well, in terms of similarities, I can see that they are all straight lines. So we have constant change because constant change gives us straight lines. Oops, I spelled straight wrong. That's kind of funny. Okay, so the constant change in each graph tells us we have straight lines. What patterns do we notice? Well, that kind of depends on what your eyes see. We do know that all the graphs go from 0 to 5 weeks. It told us that. Let's see, 2 of them are showing an increase and 1 is a decrease. I don't know if those are patterns or not, but when you're looking at this, it's just what do we see? I don't know if there's other patterns. I think the big pattern is that it is a constant change. I think that is a pattern that we see. In every one, there's like an up and over that is consistent in each graph. We're going to use that. So what are the key characteristics that would be needed to describe the pattern? Well, if we're talking about the pattern being the constant change, we need to know how quickly they increase or decrease. Meaning, in 1 week, how much did it go up? Or in 1 week, how much did it go down? So what is the change and the amount of change in that time period? And then also, where does the account start? So if we think at the beginning of the semester, look at the starting spots. For LSU, it started at 0. For SGA, it started at 30. For PTK, it started at -20. So these are very different starting amounts for week 0. So those are the different things that we need. Now, first we're going to start at the beginning, which is always a good place to start. I feel like there's a song in there. Where do each of these account balances begin? Oh my gosh, I just said that. This is also known as the Y-intercept. Now, it's the Y-intercept because if we think about a coordinate plane, the Y-intercept is the y-axis. So you'll notice that all of these, the leftmost vertical graph here, is in fact the y-axis, so we have ourselves y-intercepts. So where do they start? Well, for LSU, again, our y-intercept is going to be 0. Recall that the y-intercept is noted by the letter B. I don't know if we know that yet, but the starting balance, let me just go with 0. Starting balance is 0. For SGA, it's a positive 30, and for PTK, it's a -20. So make sure you're paying attention of whether or not it's positive or negative. That's going to be important. Now, the y-intercept is that point that the graph crosses the y-axis. So again, if I have a coordinate plane, the y-axis is our vertical piece. So if I draw a graph, that place where the graph crosses the y-axis, that is our y-intercept. We often will call this our starting point, our starting value, our initial amount. Those are some key words that you might hear that reference the y-intercept. Now, we often will call the y-intercept B. I don't know why it's noted that, but it always occurs when x equals 0. So when you think about your ordered pairs, an x value of 0 means I don't move left or right at all. So the y-intercept will have an ordered pair of 0, B, where B represents the y value of that intercept. Now let's move on to the slope. So how much does each account change per week? So this is known as our slope or our unit of change. So let's start with LSU. Now the slope is talking about per week. In 1 week, so going over 1 week, how much does it change? So from this point to this point, what is my vertical change? And for LSU, it goes up 5 and then over 1. So our slope for LSU is 5 over 1. Slope is generally a fraction. A lot of times if it's over 1, people will just write it as that that whole number, or the integer. That's really up to you. But you do go up 5 and then over 1. For SGA, if I start here at 30, to get to the next point, I have to go down 10 before I go over 1. So that slope is going to be a negative 10. For PTK, if I start here at negative 20, the next spot, how did I get from one point to the next? I had to go up 15. So I would go up 15 and then over 1. So that slope is a positive 15. When you look at each of these, how are the slope of the values of the slope reflected in the graphs? Hopefully you've recognized that if they are, if the from left to right, if they're going up, you have a positive slope. And from left to right, if it's going down, you have a negative slope. Also, the bigger the number, 15 is large. Notice the steepness of the line. 5 is smaller. It's a shallower steepness. So the bigger the slope, the steeper the line. So that's kind of the idea. So you can check positive or negative, and also the steepness based on the graph. So recall, the slope describes the steepness of the line. It's the ratio of the change in y values over the change in x's. And we often will call this the rate of change in the linear model. So it's important to kind of pay attention to that slope. Because it is the rate of change, we often will also say, change in y over change in x. That's how I refer to it a lot. Change means subtraction. So if you are given two ordered pairs, if you find the difference, you can do that. Now, one thing I do want to point out is you notice these little numbers here. So I have y2 minus y1 over x2 minus x1. So these are just ordered pairs. x2, y2 is just an ordered pair. Those little 2's just tell them that they are together in an ordered pair. And then x1, y1, that just tells us they are together in an ordered pair. So that's the importance of that formula. Let's go ahead and find the slope between weeks 1 and 3 on each graph. This is kind of a bonus lesson here. So in week one for SGA, I have the points 1, 20. And then in week 3, the x value is 3, and the y value is 0. So if I think y2 minus y1 over x2 minus x1. So I'm going to go x1, y1, x2, y2. Plug in what I know. Let's substitute in the values. So 0 minus 20 over 3 minus 1. Negative 20 over 2, and that gives me negative 10 over 1, or negative 10, which is exactly the slope we found earlier. So I just wanted to show you how the formula works. Let's do the same thing for PTK. In week 1, so when x is 1, my y value is negative 5, and in week 3, when x is 3, my y value is 25. Again, if I do x1, y1, x2, y2, I can substitute in y2 minus y1 over x2 minus x1. Notice I said minus y1, and y1 is negative, so 2 negatives does give me a positive. So I have 30 over 2, which simplifies to 15 over 1, which simplifies to 15, which is the same slope we found earlier. So whether you're using a graph and you're counting the vertical change over the horizontal change, or you use 2 points, you're going to get the same thing.